obviously on the homework quiz, the domain is limited. This is on the back of your notes from yesterday. Yeah, that's fine. On the homework quiz, they limited the domain for you. They told you only from -2 to 6. But sometimes with certain types of functions, the domain is limited simply because if x is a certain value, the function would be undefined. What value of x would make this function undefined? First of all, what makes a fraction undefined? Lucas?
If it's over 0.
If it's over 0. So what x value would make this denominator 0? 4, exactly. So your domain is all real numbers except x cannot equal 4. Because if it did, that would give you 9 over 0, which is undefined. So what I'll show you with this is how that will look if you're looking at a graph and also if you're looking at a table. So here's the function I'm typing in. By the way, when you type in a rational function like that, you need parentheses around the numerator and parentheses around the denominator. Because if you don't have those parentheses, it's just going to do 2x plus 1 divided by x minus 4. Okay, so you need numerator in parentheses, denominator in parentheses. So if I show you this, look what happens at 4. Okay, it skips it really. As it gets closer and closer to 4, it shoots down towards negative infinity. And on the other side, as it gets smaller and smaller, closer to 4, it shoots up towards positive infinity. There actually is no value at 4. If I do second trace, and I want to find the value of the graph at 4, watch what happens when I hit enter. Nothing. It's blank. 4 comma blank, because there is no point there. Watch what happens on my table. Let me set my table starting at 2, changing by 1. Perfect. Look what happens at 4. Error, it says in your column. That's because 4 is not in your domain. Are we clear on that? And on a radical function, our domain is limited because what would be the problem if you're trying to take the square root of numbers? What types of numbers can't you take the square root of? Write this down. In the denominator, cannot equal 0. So essentially, to figure out what can't be in your domain, x minus 4 cannot equal 0. Whatever your denominator is cannot equal 0. So when you solve that by adding 4 to both sides, you get x cannot equal 4. What type of numbers can you not take the square root of? Negative. So x plus 4 cannot be less than 0. Correct? Because if you try to take the square root of a negative, we'll show you. Square root of negative 4, non-real answer. That's an error. Okay? So if I solve that, subtract 4 from both sides, I get that x cannot be less than negative 4. It can be negative 4 itself. Negative 4 plus 4 would give you 0. The square root of 0 is possible. It's 0. But it can't be smaller than that. So negative 5 would be a problem because negative 5 plus 4 is negative 1. Square root of negative 1, problem. Okay? So likewise, I want to show you on a graph of this what will happen if the graph does go less than negative 4. It doesn't exist. The entire graph doesn't exist over here. It stops at negative 4. And the table, if I go back to negative 4, okay, I have numbers at negative 4 and beyond, but prior to that, it's going to be errors the entire way because it's not in the domain. Okay? For now, those are the only two scenarios where you have a limited domain. If there's an x in the denominator, because denominators can't equal 0, and if there's an x under a radical, because what's under the radical cannot be less than 0. Are we good? All right, so that's all I needed to say about that. There were 2 homework questions on there. On this one, I would just say 2x plus 6 cannot equal 0, and I would solve that to see what x can't be. X can be anything else but whatever I'm going to get there. And on this one, I say 3x minus 10 cannot be less than 0 and solve. Okay? To find the domain. X can be anything but those numbers. All right. So, we move on. Switching gears to average rate of change. In one word, average rate of change is the same as slope. Very good. So the first thing we're going to do, obviously, is to remind you. Oh, God willing, you don't need a reminder, but I'm just not going to put anyone on the spot, and I'm going to tell you what that slope formula is. y2 minus y1 over x2 minus x1. Slope between 2 points. Sometimes you guys, have you ever seen this notation? Does anyone, what does that triangle mean? Change. It's delta. It's a Greek letter, which means change. Change in y over change in x. So calculate the average rate of change for the function shown over each of the intervals and determine which interval has the greatest. When you're looking at a picture, you can just count the slope, right? So from an x of 0, which is here, there's my y-axis, to an x of 4, 1, 2, 3, 4, puts us at that point. Rather than finding the point, and doing my slope formula, I'm just going to count. Left to right, there's a rise of 1, 2, 3, 4, 5, 6. So there's a positive 6 change in the y, and a 1, 2, 3, 4, a positive 4 change in the x. So 6/4 just becomes 3/2. Then from 4 to 7, so there's my 4, 5, 6, 7 would put me here. Again, I can count up 3 over 3. Positive 3 over positive 3, which just reduces to 1. And 7 then to 13, 8, 9, 10, 11, 12, 13 will put me here. That's a rise of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Up 5 over 6, and that doesn't really reduce at all. So which one's the biggest number? No. 3/2. 3/2 is 1.5. This is 1, and this is like 0.833333. Yes? If you actually did the division out and saw the value of those fractions, this is the biggest. Now, if I were to just connect these first 2 points with an approximate straight edge, connect the next 2 points with an approximate straight edge, and connect the next 2 points with an approximate straight edge, when you're just looking at it without even counting, how do you know what is it about this segment that would let you know that it has a steeper slope, bigger slope than this one or this one? Well, not necessarily closer together, because if I just went between 0 and 2, those are close together, but that would not be as steep as of a slope as this one. I actually kind of already gave you the answer because I keep saying the word steep by accident, right? The steeper the segment connecting the 2 points, the bigger the slope, okay? So if you're ever just looking at something, you can gauge it that way. This one would have been tough, though, because they're all very close looking, okay? 1.5, 1, and 0.8. They're definitely all pretty darn close. So that answers E. The average rate of change gives a measurement of what property of the line they're looking for, slope or steepness, I'll put. Okay? So we have to be able to do average rate of change from a visual. Okay? We also have to be able to do average rate of change from a function. And here we have two functions, and we're going to do part one. We're going to calculate the average rate of change along this interval on f of x and on g of x, and we're going to compare them and see which one is steeper from -2 to 3. Okay? So, starting with f of x. Before we can calculate the slope, we need to find the points. So, your interval is from -2, so that's -2 comma something, to 3. That's 3 comma something. How do I find the y coordinates that pair with those? Chris? Alexa? Oh, go, Chris.
Plug in 2 for x and f of x.
Yeah. Yeah. And we're on the f of x function, so right now we might as well not even look at g of x. Exactly, just plug them in. You know the interval of the x coordinates you're looking for. You just have to find the corresponding y. So 5 times -2 is -10. -10 plus 7 is -3 to pair with the -2. When you plug in 3, you're going to get 15 plus 7, which is 22. And now just calculate the slope. 22 minus -3, that's y2 minus y1, over x2 minus x1 is going to be 3 minus -2. That's 25 over 5. That's a slope of 5. Are we good? And it wants us to compare that to g of x. So, same thing. We're still going from an x coordinate of -2 to an x coordinate of 3. It's just being that this is a new function, we need to find our new appropriate y coordinates on that function. So -2 gets plugged into the g function. What's that going to give you, Jack B? What's g of -2? Say it again. Do you know what you're trying to do with -2?
No.
You're finding g of -2, so you're plugging it into here. So it's talk out loud through your mental math calculations. Negative what? Well, no, we're getting rid of the x. We're replacing the x with a -2. 2, and we're replacing the x with -2. Order of operations, what comes first? Okay, so what are you going to bring to the second power? And what does that give you? And then what are you going to do? And what's that give you? And then what are you going to do? And then what does that give you? Beautiful. We made it. G of 3. I don't know, doesn't really fly with me if you couldn't tell. Vince, what's G of 3? Very nice. Okay, slope formula, 19 minus 9 over 3 minus -2, 10 over 5, 2. Which one's bigger? F of x has a steeper slope between -2 and 3. Good, good, good? Yeah.
Would you have to do like brackets around the parentheses because of the equal sign?
So this is where it gets a little tricky. You have to know the context of what we're doing. We're not talking interval notation here. We're talking what are the points. And anytime you're doing a point, it's always parentheses. You know, it's not about including or not including. This is the coordinate pair. Okay? So that is confusing. Now we're not going to do it because I don't want to waste the time on it. But if we were to find the average rate of change on f of x from 1 to 5, we would also get 5. If we were to find the average rate of change on g of x from 1 to 5, it would not equal 2. I'll tell you that. Question is why? Look at your functions. Why does the f of x have an average rate of change that seems to be always 5?
F of x is linear.
Perfect. F of x is a line. That's mx plus b. That's a slope of 5. So it's always going to be 5. G of x is a quadratic. And the slope on a quadratic is constantly changing. It's negative, it's negative, it's negative, it's 0, it's positive, it's more and more positive, it's getting steeper positive. It's always changing. So depending on the interval for a quadratic, it's going to be different. But on a line, the interval doesn't matter. If you're looking at a line, if you calculate the slope from there to there, it's going to be the same as if you calculate a slope from here to here. Doesn't matter. Okie doke? So, just, you already know that about lines, just something to point out. Okay, so speaking of lines, here's a table of a linear function. So that exact property right there, that the slope always has to stay the same, is true for this one. It's a linear. So based on the fact that we do already have 2 points, we can calculate what this slope is. y2 minus y1 is 1 minus negative 5. Over x2 minus x1 is 5 minus 1. That's going to give us 6 over 4, or 3/2. Our slope needs to be 3/2 everywhere. So when we're going to fill in the blanks here, like this one, we'll call that y right now, we need the slope formula to equal 3/2. So that's going to be y minus 1 over 11 minus 5, and that needs to equal 3/2. How do you solve something like this? Cross multiply. So, just for the record, 11 minus 5 is 6, right? So I'm going to save myself some writing. 3 times 6 is 18. 2 times y minus 1 is what, Eric? Good, he distributed, which is perfect. I add 2 to both sides. I'm going to get 20 equals 2y, so y is 10. And now that I have that one, I can move on to the next one. And here I'm missing an x. So, Tess, can you set up the slope formula for me between these 2 points? Let's back up. M equals. So what is y2? What is y1? What is x2? What is x1? Perfect. And what is this supposed to equal? 3/2. Nice job. 22 minus 10, for the record, is 12. 12 times 2 is 24. 3 times x minus 11 is 3x minus 33. Do we get the point? Solve for that. Add your 33. Oh boy, 24 plus 33. 24, 34, 44, 54, 57. And then 57 divided both sides by 3 is going to give us 19. And then we would carry on to the last and final point. Okay? Keeping that slope the same, understanding that for linear. Exercise 4. See what this table is talking about. Temperatures measured on a summer morning. Determine the average rate of change between 8 a.m. and 10 a.m. and between 9 a.m. and noon. When is the temperature hike, in your opinion, having not done any calculations, when is the temperature going to jump more quickly, I guess? From 8 to 10 a.m. or between 9 and noon, do you think? Probably 9 and noon. I would agree that that seems like what would happen, but you don't know. Every day is different. So from 8 to 10, that's here and here. What would the y2 minus y1 be, Faye? We're going between 8 and 10, so it's this point and this point, not the 16. 19 minus 15, very good. That's y2 minus y1. And x2 minus x1. Jack Taylor? Perfect. Which pretty much, now this, for the first time in what we're doing today, this has temperature attached to it, or units. So temperature would be in degrees, and the time would be in hours. That's a degree symbol. So that's 4 degrees every 2 hours. You guys know the sign for like miles per hour. It's just like a slash mark, right? Per is just a slash mark because it comes from division. 4 divided by 2 is 2. Degrees divided by hours is degrees per hour. 2 degrees per hour. That per symbol comes from division, FYI. Okay? And then 9 a.m. to noon would just be 31 minus 16 degrees over 12 minus 9 hours. With average rate of change, if there are units attached, you need to attach the units. So that would be 15 degrees every 3 hours, which is going to reduce to 5 degrees per hour. And you guys nailed it, 9 to 12. And then lastly, while I'm passing out your homework, this says that the average rate of change is getting larger as x gets larger. How can we see that? How does the graph show that? Chris, go ahead.
Line gets steeper.
Very good. Line's getting steeper. That's it. That's all you have to say. Corrections due tomorrow, yes? Tomorrow's Thursday, we start thinking about the weekend. Life is good.
And if you only have corrections that you already did it, if it's just like a one